the opportunity here, Martin and Globant, to represent QIO and what we do. That is not my wife. Well, my employees tell me. QIO is a startup. I formed the company just over 3 years ago. It stands for Questions, Insight, Outcomes. So some madness in what we did. We're all about digital manufacturing and what we do there. We've been recognized recently with some awards, which are obviously there. So just go through the history here. My co-founder is Rick Haythornthwaite. No pressure on me. He's the chairman of MasterCard and Centrica. So you can imagine having to deal with Rick. And I just spoke to him about an hour ago. How's it going, Baz? It's going fine. So he sends his regards. So he's my co-founder. I've known him for about 17 odd years. Fantastic guy. And he's helped me mentor and grow this company. In terms of starting, we started with a clean sheet of paper, absolute blank sheet of paper in starting this company. There's no pre-written code. We're 52 people in the company now. Most of us have got industrial experience. What that means is we work for big industrial companies like Emerson or Schneider or GE, big industrial companies, and they've been around for 100 years plus, okay? And so they have a certain way of operating, a certain way of doing things. They make physical products, which makes this world go round, okay? So you all came in on planes or have been on planes and those jet engines. How many parts do you think go into a jet engine? Anyone? Okay, it's just the ones you can physically see, and when you assemble it as assembly point, it takes about 19 days to assemble one. 250,000 parts at assembly. Wow. Okay. How many PDFs go with the life cycle of a jet engine? So life cycle of a jet engine is about anywhere between 10 to 15 years, depending on how it's been operated. 64,000 pages, PDFs. Have to go with it. Just give you scale of what these industrial companies do, all right, on a day-to-day basis. Okay. Now, as QIO, our mission is to liberate industrial engineers. Volkswagen Group, how many employees in Volkswagen Group? Roughly. Anybody guess? 635,000 employees. They own Porsche. They own VW. Okay, so obviously they own Audi. Okay, they own Rolls-Royce, the cars. Okay, so it gives you a scale of folks. How many of those are people we would classify as blue collar? In other words, they're working in the factories. They're engineers. Of the 635,000 people in Volkswagen Group, how many think are working in the plants? 70%. Percentage-wise? 20%. 20%. Over 50%. So 50% of that workforce are what I call the engineering team, plant operators, technicians, putting things together, haven't got access to the digital tools we all are used to at work. So I decided with Rick to create a company which liberates those engineers, gives them the tools, empowers them. First, these suite of tools are all AI enabled, are called Foresight Suite, and they allow us to, first thing for an engineer is safety. It's all about safety. Okay? And so how do I make sure that I've built things correctly to the standards which have been dictated by the industry or by the organization itself? And so we call that Foresight Performance. All about the quality of how things are being built. Best practices. When I was a student, I worked for McDonald's, done some money, and there was an operational checklist. How I'm supposed to make a burger. Okay, all right. Well, those operational checklists also exist when you go build a jet engine. All right. They're manual. All right, they're in spreadsheets. I've just digitized a customer who had 585 spreadsheets on one standard. Okay, that's how their work gets done. So imagine digitizing that. Then you go look at the amount of energy which goes and consumed in these buildings, in these facilities, especially if you're making steel or you're making cement, anything with alloy, huge amounts of energy going in. And so if we can build a predictive model for how energy is consumed, we can make a big difference to the world. Yeah? And so we've built, I won't go through all the products here, but a whole suite of products which are integrated, and the customer can start at one point and can evolve with us in their digital journey, fast track their journey, targeted to those engineers. That's QIO. Why now? Why would an industrial company look to transform itself into digital after they've been around for 100 years? Okay, why would Rolls-Royce, big engine manufacturer, look to digitize themselves? Okay. Firstly, there's a convergence between what's called information technology, SAP, Oracle, and things like that, Salesforce, and operational technology, things like which run your plants. They're called SCADA systems, okay? And they're real-time, and they're all proprietary, most of them, yeah? And those two worlds are coming together. And so if you're in SAP and you're doing your planning, how do you know real-time what was actually made? You have to bring two systems together, yeah? Then the technology, which is what we've been about, and you've heard a lot today, around all the technology which is coming together around cloud. But what's not being heard of is smart sensors. So I'm working with a company in the UK right now, which has got AI at the edge. Something you've not heard of. AI at the edge meaning you've got a water meter sensor with bacterial signatures in the sensor. So a bunch of biochemists have created fingerprints to spot bacteria in the sensor at the edge. Can you imagine the transformative effect of that? Water sensing is usually done through sampling. Okay? Now I've got the power to put those sensors at the edge and decide whether we have got a problem with bacteria, about 8 bacterial strains. Created by a British university, we're bringing that to market. Fracking is a huge market for it, okay? Just to show you smart sensors. Another example is if I'm stood in front of a major turbine and I'm looking for oil gauge issues within that turbine, the oil gauge, to get to that oil gauge, requires 3 parts to be removed before I can get to the oil gauge. What if the world existed that there was a nanosensor with intelligence communicating directly to the worker and is telling the worker the oil gauge information before he's servicing it? Wouldn't that change his game? So imagine smart sensors with AI at the edge. It makes the industrial processes and industrial products much, much easier and smarter to use. That is the power of edge AI, as I call it. Then there's competition. There's competition where you've seen in Asian countries where you've got leaps occurred. You know, the fixed line in Vietnam was completely gone. They didn't go through it. They went straight to cellular. So you've got competition where Chinese companies, Indian companies are going straight into this cloud AI world. How do you compete? Now we're going on with reshoring as manufacturing comes back to the West. Well, how do you compete? And so you've got to use some of these technologies. Building new products with these capabilities in. You'll see over the next 5 to 6 years, your washing machine, your fridge, your house becoming more and more sensors, more and more intelligence. Okay? And so that they can offer relevant products to you and go what I call one-to-one marketing. Okay? So you got CapEx, business models, use per use model. So when you buy a jet engine, it was sold on a basis of a capital spend. They've moved to power by the hour. They get paid when the engine is flying. So completely changing your business model as an industrial company. You've got massive billions and billions of dollars of service, long-term service contracts tied to them. Those contracts are at risk because of AI. You can improve your service and your maintenance on them dramatically better if you've got smarter intelligence around your products and capabilities when you service them. So those industrial companies are feeling the threat of these technologies around their long-term service contracts. And it's a big, big number. Customers, big oil companies predominantly, are now realizing that when they were upstream, midstream, downstream, and retail is how they operated their businesses. Hold on, I've now got to become an integrated value chain across upstream down to retail. How do I do that? Okay. So these changes are occurring now, and most industrial companies I work with, manufacturing companies I work with, are starting the journey towards digitalization. So what would a digital journey at a high level look like, at a very high level? Firstly, a jet engine roughly has sensors in it, okay? It's going to have smarter sensors in it in the future, but it does have sensors. So a jet engine has about 1,000 sensors in it today. Okay? So industrial equipment has sensors. Those sensors are connected to something from a real-time point of view. So it's connecting to that data and bridging that data with whether environmental data, i.e. weather data, or IT data from your SAP systems, bringing them, fusing the data together, and processing that data into, as Martin pointed out, agnostic platforms. Okay? But then it's making sense of that data and unlocking value and improving safety. And so the Boston Consulting Group, and it's a complex slide to see, said what are the type of applications which will be created in the future, the next generation type of applications, which will be created in the future to unlock that value. And they talk about predictive maintenance, self-optimizing supply chains. These applications are coming to the fore using the data. But industrial companies and manufacturing companies are slow. On the one side of this chart, you can see that the adoption is a top priority to be digital. But to use that data in terms of intelligence, only 29% have actually started or done something about it, and most of them are struggling to scale it, which means move it to all my assets, move it to all my locations, move it globally, and move it into my customers. So they're struggling with scale. I was with a major oil company, and his number one criteria for picking software wasn't feature list, it was scale. Because they have to connect so much data across so many locations at speed and make sure it's accurate and complies. Okay, there's a whole load of data classification needs here. So there are a whole load of hurdles in that journey. Those hurdles are around the lack of standards. We, in the consumer enterprise space, benefit because we have something, Sir Tim Berners-Lee, no pressure on me, he's on my board as well, okay, founded the internet, if you don't know who he is, all right, and he created the HTTP protocol. And before he put his name on QIO, I spent 3 hours with him, and you can imagine that interview, yeah? It was not easy, all right? But one of the things Tim said is that this one of the things I said to Tim was, the industrial space does not have standards. And it will take another decade or more for the industrial companies to collaborate, the Emersons, the GEs, the Schneiders, the ABBs, the Honeywells, the Rockwells, to create standards. And they're starting. Okay, they've started on a wireless standard. Why on a wireless standard? Because guess what happens in a refinery? It's the wiring, and the rats sort of eat through the wiring. Does happen, okay? So if you create wireless, secure valves and compressors and so on, and you can put a wireless in a plant, it's called wireless HART. That's the standard which has been created. There's about 500 million of these now deployed in production. You can actually unlock significant value and improve safety. So standards are coming together, but it's slow. So if you're a poor industrial engineer, I've sort of highlighted him there, his world is pulling data out of all these disparate systems and putting them into what? Excel. That's what he lives his world by, Excel, all right? And you can go anywhere in the world, in any plant in the world, and say, how much Excel do you use? And I was with one guy, and his name is Mohammed. I was in the Middle East, and he had a spreadsheet, beautiful spreadsheet, 415 columns, on which he was monitoring the calibration on his furnace for one of the biggest steel plants in the Middle East. Wow. Okay? That's what's going on in his world. So if I can give him better tools to Mohammed, okay, then I've got a chance of achieving better safety for him. There's complexity of data. Complexity of data is huge. You've got to bring industrial data, environmental data, unstructured data, different types of data, and you've got to make all that work. So it's a big data challenge. Big data in terms of complexity of data bringing together. So we've created a roadmap with our clients. This is proven. First thing is, just mentioned earlier, start incrementally, and we call that think big, start small, scale fast. It actually comes from McDonald's. And it's around high-value use cases. What we mean by that is that the return is within a year. So whatever you're going to invest, you can get back within a year, okay? Because the value's there. The time to value is fast. They become the demonstrators. These become the areas of innovation, disruption. So I had a client who had no digital cells. They look very similar to these, okay, 3 years ago. They've now got 112 digital cells across their 60,000 employees. Okay? And so we can create demonstrators where people can get, an organization get around and scale them. So next one is to build sovereignty. Sovereignty meaning that the ability to understand what data belongs to you and what you're allowing to share with others. Also protecting your intellectual property, because these algorithms are like your Coke secret. So if you don't understand your intellectual property and you're signing contracts, you better be careful. So learn what is important in terms of those algorithms, critical. Owning customer relationships become more and more transparent, and who owns the customer experience at the end of the day is going to be important. Building up analytical applications is really, really key. I've talked about some of the examples there. All of us in this room have a Myers-Briggs, 4 numbers or 4 letters, yeah? We're all introverts or extroverts, okay? Changes which environment you're in. Our view is, why doesn't an industrial asset have a digital personality? We call that PARCS: performance, availability, reliability, capacity, and serviceability. It's kind of the heart of what QIO created, because we believe industrial assets like compressors, valves, motors can be trained to create digital fingerprints. Okay? And last thing is servitization, making money out of that digital twin. Now we know what one is, okay? So how do you monetize that as you go forward? Okay. Case studies. So here is the world's, so all glass in IKEA is provided by ARC. Okay, they've got 5 plants around the world, and essentially they break a lot of glass every day. Believe me, okay? Why? Because it's manual controls on the fire finisher, which gives the finish, the quality of the glass. We're able to go in there, analyze that data, and dramatically reduce their energy costs, but also improve their safety and also improve the quality of the glass. Okay? Next one, key client for us is Rolls-Royce. How do we enable the engineers worldwide to share data? So now we have 3,000 engineers. We will have 45,000 by the end of next year, collaborating on standards worldwide. We have tools by which they can model and simulate launch of engines. We have tools embedded in them to allow them to identify excess inventory across all their locations. Last one there was just one example, is a petrochemical company in Singapore, which basically was looking at a quality problem which affects human health, and that was taking them forever and ever to go figure out. We did the modeling, did the AI engine, it's in production, and it's dramatically improved their quality of their product and reduced risk to their customers. So hopefully those are some examples. And thank you very much for the time here and around QIO, what we do, and the journey of digital manufacturing. Thank you.